All right, welcome to another video in pre-calculus. So in this video, guys, I'm going to work out one of the problems in the textbook. This is number 37 on page 317 in the book. So I'm going to start reading it. Many sunglasses are made with polarized lenses, which reduce the intensity of light. The intensity of light emerging from a system of two polarized lenses, I, can be calculated by I minus I sub naught, which is at that zero right there, sub naught minus I sub naught over cosecant squared theta, where I sub naught is the intensity of light entering the system of lenses, and theta is the angle of the axis of the second lens in relation to that first lens. So this red line here is the axis to the first line, right? And then the blue line is the theta that's as that second lens is the degree of which that second lens is turned in relation to the first degree, the first lens. Okay, so A, it says simplify the formula for the intensity of light emerging from the system of two polarized lenses. So I have the formula. Whoops, let me back up here. I have the formula that the text gives us, and have it written here. And so what I'm going to do is I'm going to simplify this formula like I have my other ones. So as I look at the formula, there's really not much I can do because there's no, well, hold on a second. There's no trigonometric function that I know of that relates to these terms, because since I'm dealing with such a specific physics problem, there's no I don't have any trigonometric functions. In fact, I'm going to go to here. Now I can see my trigonometric identities. There's only one in my highlight. There's only one trigonometric function here. And as I look at my identities, one comes to mind immediately, which I'm going to use here. Let me rewrite my formula. I sub naught minus I sub naught over cosecant squared is the reciprocal of sine. So I can say 1 sine squared theta, right? So as I proceed, 1 sine theta, what I want to do is I want to multiply, I'm going to do this in red, I'm going to end up multiplying by sine squared theta over 1 so that I can remove this term from the denominator position, and it'll move it up here. So then I multiply everything up here by 1 sine squared theta. Okay, so then my new formula will be I sub naught minus I sub naught sine times sine squared theta. Okay, scoot up a little bit. And as I continue to analyze my problem, I see here that I have a like term. I have I sub naught, and then I have I sub naught here, which I can then factor out. And that's what I'm going to do. I'm going to factor I sub naught out times 1 minus sine squared theta. Okay? So that's my new formula right now. It's I'm not quite done. I'm not quite done simplifying this, because this here actually simplifies also. In fact, if I look at one of my Pythagorean identities, I see one here, sine squared theta plus cosine squared theta equals 1. I can alter this one by moving my sine over to the other side of the formula, giving me cosine squared theta equals 1 minus sine squared theta, which this, as I see, is the same term that I have here. So then I can replace my term here with cosine squared theta. And so then my new formula is going to be I sub naught cosine times cosine squared theta. And so now I have a simplified formula that I can use to answer any questions that the problem might give me. And in fact, if I look at part B of the question, in fact, let me go back here. If I look at part B right here, It says if a pair of sunglasses, so now I have a pair of sunglasses, contains a system of two polarizing lenses, okay, with the axis of 30 degrees to one another, what proportion of the intensity of light entering the sunglasses emerges? So, so now I have a theta. I have a theta to add to this. Okay, and that theta is 30 degrees. So my new problem will be now I sub naught times cosine, okay, cosine of 30 degrees, and then I have to square that, of course, right? And so the cosine of 30 degrees, if I go back to my unit circle, um, that's not my unit circle. It's not going to be very helpful for me. So hopefully I have my unit circle memorized. Cosine of 30 degrees is pi over 3 over 2 squared. Okay, so then I continue my algebra work at this point. I sub naught, and then of course, as I already know that I have to disperse, distribute my exponent into my terms, each term in there, and I'm left with 3 times 3 over 4. So the answer to B, the question was, going back to my problem, is what proportion of the intensity of light entering the sunglasses emerges? And that's what this term is right here. That term actually tells me that 3/4 of the light emerges with these two lenses, and one of the lenses turned at 30 degrees from the other. Okay, well, I hope this working out of the problem 37 helped in your studying, and good luck in your studying.